We have discussed the method for finding determinant. We did it for 2 by 2, 3 by 3, 4 by 4, and so on. We can apply that one. Here we are using another method for finding the determinant by the method of row operations. Very interesting one, very easy one. Sometimes this makes our life very easier. But we have to understand it. We have done already row operations in matrices. There we say if we make the row operation, we can evaluate the system of linear equation. There are 3 row operations. We can interchange 2 rows. We can multiply row with a number, or we can multiply row with a number and add to other one. But these row operations now they are different. In determinant they are different. There the system was having no change when we make the row operation. Here the value of determinant is going to changing. We have already discussed that we find the determinant only for the matrix which is a square matrix, 2 by 2, 3 by 3, 4 by 4, and so on. Number 1. Number 2. When we make the row operation, then we get a negative sign. When we just make any 2 consecutive rows, we get the value will be changed. For example, determinant value is 2, they become minus 2. It is minus 4 become 4. 1 minus sign is being multiplied. Number 1. Number 2. When we multiply any row of the determinant, we can multiply it. But when we say we multiply a matrix with the number, then each entry of the matrix is multiplied by that number. This multiplication, that multiplication is different. But here, when we multiply any row with the number, the value of the determinant will multiply with the same number. For example, we multiply row with number 4 and determinant value is 2. Now the new determinant whose any row or any column is multiplied, the value will be 4 multiplied by 2, that will be 8. But one thing which remains the same in determinant in the matrix is row operation. That we multiply row with the number, add to another row, the value will not change. Same is determinant. In determinant, multiply row with the number, add to the row, the value of determinant will not change. I will explain you with the help of example. So the first row operation is that we having here number 1, if we find matrix A, 1 is obtained by from matrix A by interchanging 2 rows, by interchanging 2 consecutive rows, then determinant of A1 is equal to minus determinant of A. So I can give you an example for this purpose to explain my idea. Example for this one, I'm having here matrix A. I have matrix A. This here is 1, 2, 3, 0, 1, 2, and then I'm having here 2, 4, and 8. So I just have new determinant. We interchange 2 rows. We're having here R1, interchanging R2. So get here A1. So my A1 is equal to 0, 1, 2, 1, 2, 3, and 2, 4, 8. Now we check the determinant of both of them. We find determinant of A and determinant of A1. When I find determinant of A, so my determinant of A, I open from the first column. So is 1 into cofactor, is 1 into 8, minus 8, then is minus 0, then with 2, plus 2 into cofactor. The cofactor is 4 minus 3, 4 minus 3. I get the result. This will be 0 minus 0 plus 2. The value is equal to 2 for matrix A. I find determinant of matrix A1. So determinant of matrix A1, which we find by interchanging 2 rows R1 and R2. Again from the first column, we're having 0 into cofactor, that means 0. Then we have minus 1 into the cofactor of minus 1 is, this here is 8 and this here is minus 8. 8 and minus 8. then cofactor of 2 plus 2 into cofactor of 2, this row is column is gone, row is gone. We get here 1 minus 4, 3 minus 4. So I solve it. I get here 0 minus 0, and get here 2 into minus 1 is equal to minus 2. I compare this result 1 and result 2. From 1 and 2 I can see from 1 and 2 what I'll get. I get here determinant of A1 is equal to minus determinant of A. That is, the result we have said that if we interchange two rows, then we are having here the determinant is multiplied by minus 1. That was the idea, and we interchange R1 and R2. I found the result, the determinant of A1 is equal to minus determinant of A. So this was the first row operation which I said. The second operation which we can define is that when we multiply, we find a matrix number 2. We're having if the matrix A2 is obtained, if matrix A2 is obtained by multiplying row of A by constant k, by multiplying row of matrix A by k, then we have determinant of A2 is equal to k times determinant of A. Again, I take an example, and with the help of example, I solve this one. So I take here that I just have matrix A, and I find here matrix A2. So it's my matrix A2. I'm having here my A2, the matrix which I obtained. I multiply the first row by 3. 3, 6, 9, 0, 1, 2, 2, 4, 8. What I did, I multiply my first row by 3. So we see the determinant, and we see how the value of the determinant is changing. We're having this determinant of A2. Determinant of A2 is equal to, opening the first column, we get 3 into 8 minus 8 minus 0 into any cofactor will remain 0. We get here plus 2 into cofactor of 2 will be 12 minus 9. So it will get, I get here 0 minus 0 plus 2 into 3, and 2 into 3 is 6. So this is my determinant of A2. What is the determinant of A? I've already seen my determinant of A is 2. This is why I calculated this equal to 2. So I can write here my determinant of A2. I can write like this one. Determinant A2 is equal to 6, and this is 3 multiplied by 2 is 3 into determinant of A. So we say determinant of A2 is equal to 3 into determinant of A. The same idea which we have just mentioned, that when we multiply the value of k, we say our k, this is equal to 3. We take the value of k equal to 3, and this is my k. So I get here determinant of A2 is equal to 3 times, this is my value of k in determinant of k. So these two properties we have discussed by the row operations. We have in number 1 that when we interchange two rows, we get here minus sign. We interchange R1, R2. We get here, this is determinant of A will be obtained by interchanging first two rows. This was here R1 and R2 was interchange. And then we find determinant of A1, that was minus 2, and we get the relation determinant of A1 is equal to minus determinant of A. The second was determinant of A2 is obtained by multiplying the row matrix by matrix A by any number. This determinant of A2 is equal to minus k times determinant of A. Number 3 is that if we multiply row with the number and add to the row, the value of determinant of change. Number 3, if A3 is obtained by by multiplying row with a real number and add to the row and add to another row of matrix A, then the result of this one is then we are having here determinant of A3 is equal to determinant of A. So value of determinant will not change. In this case, we say the value of determinant of is not changing. I take an example, and we just write here. We take this matrix A, and for number 3, we take here example, and we find A3. I find here A3. My A3, I say this is equal to, I take here 2R1 plus R2. So I can just write here this one. My matrix here is, equation is 1, 2, and 3. Then 2R1 plus R2, that become here 2 and 5, 2R1. 2R1 6 plus 2 8, and 2 4 and 8. So the last row remain the same. We are having here this is equal to 2 2 4 and 8. So we say if we open this one, the value of determinant will not change. Let us check this one. I find determinant of A, this is my A3. So I determinant of A3 is equal to 1 into cofactor, this is 40 minus 32. Then we take here by column minus 2, this is 16 minus 12. 16 minus 12. Then by plus 2, I get here 16 minus 15. 16 minus 15. I simplify this one. I'll get here this equal to 8 minus 2 into 4. And then I get plus 2 into 1. It's equal to 8 minus 8 plus 2. That's equal to 2. So what do you get here? I get here, this is determinant of A3. Determinant of A3 is equal to determinant of A. The value is not changing. You can make any row operation. I have taken this row operation. You take any row operation, perform on this matrix A. When I find the determinant of this matrix A is equal to 2, by making row operation, we perform the row operation and then find determinant. The value remains the 2. So determinant A3 is equal to A2. So we have 3 row operation. Number 1, we interchange 2 consecutive rows. We get here new matrix A1. The value is changed by minus sign, as we have did it here. Then we multiply a row with the number, and then find determinant. We multiply here row of A1, this matrix A1 by 3. We get 3, 6, 9. Find determinant is equal to 6. So we say the same. Determinant of A2 is K times determinant of A. Determinant A was 2. Determinant K was 3. The value is 6. So 6 is 3 into 2. 3 into determinant of A, my K is equal to 3. Then the last one was that when we obtained the determinant A3, by multiplying row with the real number and adding the other row of the matrix A, then determinant will not change. I took this example. I take A, I multiply by row 2 by 2, 1 by 2, and add to row 2. We get here 2, 3, 5, and 8. Change this one. This 2 plus 4 plus 1, 5, 6 plus 2, 8. And I find determinant. Determinant is equal to 2. So I get here that determinant of A3 is equal to A2. That's very strong row operation, number 3, and we will use this row operation for finding the solution of our problem. And determinant, we making any change in determinant, like we interchange 2 rows, we get minus sign. So that's very important. Or we multiply row with the number. In matrix, we multiply whole matrix with the number, but in determinant, we multiply row with the number. Just want to ask, say a few things. This is number 1. You have the notes for this lecture in description. The link is given. You can just go and download this one. You get more examples and more exercise practice. You can learn mathematics by solving the problems. Spend some time in examples. Use the examples. You just solve example yourself and then compare with the example given in the notes. And if it's wrong, then you again try it, check your mistake, and try to improve yourself until you get the solution without any extra effort, number one. Number two, because we have a serious lecture, it's lecture number 11. So this is given the playlist. You can just go to our channel playlist. You'll get all the lectures there. You can download that one. You can just watch them as you like. Number three, you subscribe our channel. Like it, subscribe it, and press the bell icon so that you can get the lectures we are developing more in this relation for the engineering mathematics. It's also true for the 11th grade students in the federal board or the other boards. Also, this is true for the A levels. Maybe sometimes the standard is a little different, but the basis is the same, and you'll get inshallah benefit from that. We like that you learn it and learn it nicely.